Hi friends, welcome to our channel Techcorner. Today we are going to discuss about the basics of electrical. Basics of anything is very important if you want to learn something. If you want to build something, base is very important. Even if you construct a house, if the base is not strong means the entire building structure will get collapsed. So even if you want to learn something, you should have a base knowledge. So today we are going to discuss about the basics of electrical, especially the terms like voltage, current, power, resistance, etc. That too in a small example which will be very much easier for you to understand. I definitely believe that even if a non-technical person watches this video, you will understand all these terms, basics of electrical very clear. Before starting the video, please do subscribe our channel. To start with, as we all know our plumbing system of a home, like we have an overhead tank which will be connected with a pipe to the tap from where we collect our water. So the same example I am going to use here as well. You will be getting all these electrical basics understand from the same example of a water tank. So I'm using this case to make you understand what are the basics of electrical. So let's start with an example. As I already told you, we are taking a water tank example. As you all know, we in our every homes or flat we have an overhead tank which is storing the water, which will be connected through a pipe to a tap which is distributed into a kitchen or bathrooms, etc. as well. The same we can relate to an electrical system, and we can clear all our basics with a similar example. So let's start with the example. To start with, as I told you, we need a water tank which can be related in our electrical system as a generator or a battery. So for example, what a water tank does, it stores water and it supplies to us water whenever we require. So same we can consider in an electrical system also as a generator. What generator does? Generator generates electricity and supplies to us as per our application. Same battery also stores energy and gives us whenever it is required. So if you take tank as an example, then we may relate it to battery. If we take a well as an example, then we may relate it to a generator. So both the case for our concept, clearing our concept, it's fine. So let us consider as a generator, water tank. So in a water tank, it will be full of water. It will be filled with water. It can be emptied. So in our case, it is filled with water. So it's nothing but in our electrical system, it will be filled with electrons. So generator, if you take an example, it's filled with electrons. So let's believe like it is filled with electrons. Then what we required is a pipe. So in a plumbing system, we need a pipe to bring the water from overhead tank to our application, wherever it is used. So same way in our electrical system also, from wherever the power is generated, we need a cable to carry the power to the end consumer. So we know in our home we are getting power from a cable. That's it. So right now we have a source which is generator. Then we have a medium of taking this power from one place to another. So where it is taking? So we have a tap here. Can you please guess what will be the tap in our electrical system? I will just hold on for a second. Please comment what you understand from tap in this system. How can we relate this tap to electrical system? It's nothing but it's load. Load is very simple. Even a light LED bulb is a load. Even an AC is a load. Even a motor is a load. So load can be the end thing which will be used, like wherever this energy, electrical energy is converted into some other form. That is what we called it as a load. So then let's start with our basics terms: voltage, current, power, etc. To understand that, so as I told you, this water tank is filled with water. That means in our electrical terms, it is filled with electrons. As we know, what happens, whenever we connect this pipe, water will flow from here, from the tank through the pipe till the tap. This will be clear. Like why it is flowing? It's just basic law. Water will flow from a higher level to a lower level. Or in our time, it will flow from a higher potential to lower potential. The same thing is happening. Whenever a water level is high at the tank or a generator, the electron starts flowing through the cable. and this flow, like what we called it as voltage, means potential difference. That means the generator is at a higher potential and this load is at a lower potential. So definitely electrons will flow from a higher potential to a lower potential. That is called voltage. Voltage is nothing but this difference, potential difference across 2 points, like from a higher point to a lower point the electrons moves. That is called voltage. So I hope voltage is clear. Because of this potential difference, that is because of this voltage only, these electrons are moving from generator to load. So voltage is required to make our electrons move from our generator to our LED bulb. If your LED bulb wants to glow, means there should be voltage. That means if voltage is there only, the electrons will come from the generator to our light. Then only we will get that electrons available at the load. So that is what voltage. Then just for example, resistance also. So resistance, what does a resistance mean? Resistance is nothing but the flow of electrons. There is something to oppose this flow of electrons, means we will call it as a resistance. Suppose this pipe offers some resistance, because the water is completely full, but this pipe cannot take entire water, or as per the load complete water. If the load is high, means we cannot take complete water at a time, because this pipe is also, the dia is small, it is also offering some resistance. Even the load also offers some resistance. Even there is a block in the pipe which is also creating an unnecessary resistance. So that resistance will definitely reduces our productivity or the efficiency of this system. So resistance is something which is offering a opposition path to the flow of electrons. So I hope resistance is also clear. So we have voltage, that means potential difference across 2 points, and that is the reason electron is flowing. Now let us come about the current. So for that I have added a bucket. Just you can consider this as a energy meter, where you are measuring the power and current. So current is nothing but we have voltages, we have electrons coming through this point. So if this single drop, if consider this, we can call it as a current. That means at this particular point how much of water is coming, that is called current. Like if you little bit, if you open the tap little bit, the water will start flowing. That means electrons is flowing from here to here, but the current will be small, because load is little bit low open, means the load is very low. Even if you increase the load, if you open the tap to a higher like completely, the flow of water will also increase. That means the current also increases. That means if load is more, means current will be also more. So one more thing it is clear from here is that there is nothing to do with source for a current, because current is completely determined by a load. For there is a particular condition, because whenever, like if you want water here, means we should need water at source also, right? That means voltage should be present, there is nothing like, or even source should be available to create a current. There is no doubt in that. But ultimately a current is something which is determined by load, really, because that's the reason. For another example, if you see the unit of generator or a transformer, it will be termed as kilovolt ampere, that is kVA. But when it comes to a load, it will be calculated as kilowatt. That is because at the source side, source doesn't know what will be the load which will be connected, what will be the current which will be taken from the source, because load varies, load depends. We cannot standardize a load to a source. So source is completely unaware what will be the current which will be supplying, but it can always tell that this much of voltage ampere it can supply. That's a whole value. But a load is something which is using this current, which is making use of this current, or which is generating this current. So there we can definitely tell what is the current for this. For example, like if you turn this tap little bit on, maybe 1 ampere, or if you consider this load as a light, it will be taking a less than ampere current. If we connect it as a motor, it will be taking maybe 5 ampere. So what here it is exactly clear that we didn't change anything, source or cable, we just changed the load, the current increases. So ultimately the main factor of current which is determining is load. So I hope you understand the load and concept of the current. The current is nothing but the flow of water, like how much of water is flowing at this particular point is termed as current as well. Then I have a bucket of energy meter. So we have another, like right now we have understood what is voltage, potential difference. At the end of this video I will be going through all these points once again. Then we have resistance, we understood. Then we have load. Now we have current. Now the main thing is power. We always call in electrical system that power is this much, power is this much. How we calculate this power? Very simple. So I have added a bucket here. So just to calculate the power, we need to know how much of water is coming and filling this, or how much time it will take. It's a simple calculation. We have voltages. The voltage means the rate at which the electrons are moving, or the potential difference across the thing. So in a simple words, if we calculate the water, how much water it is available at this point, and at what rate the water is coming, at what the speed, what the pressure it is coming, is called power. That means simply that how at what pressure it is coming is voltage, and how much it is coming is current. So power is equal to voltage into current. So at this point, how much of water coming and at what rate the water is coming, that multiplication of this will give us the power. That means this bucket is filling water in power of 5 kilowatt, means it is coming, water is coming in a speed of something, and which is in a particular amount. So this is how an electrical system basics are classified. Like we have a source which is the generator of electricity, or which generates electricity, and which will be having electrons. From that particular thing, the electrons will be moving through a cable in our electrical system, that means pipe in the pumping system, and the electrons will be taken to the load with the help of this cable, and at the load it determines how much current it should take and how much power it is consuming. So I hope you understand everything. If I tell again, voltage is nothing, it's potential difference across these 2 points. Like if you take tank A as A and this is B, means voltage difference across B and A will be the potential difference across the point B and A will be the voltage. That means the rate at which the electrons are moving, and load will be nothing but the things which we are connecting to the particular supply, and current is nothing but how much electrons and what rate electrons are taken at that particular load will be termed as current. So if I take this motor itself, if it's running in a low speed, it will be taking 1 ampere. If it taking complete efficiency, it will be taking 5 ampere. That means whenever the load or the requirement increases, the current also increases. But only thing is that whenever we require this current, the source should be capable to provide that. That is definitely required. If there is no water, if there is no flow, means definitely won't be any current generator. So voltage is also important to create a current, and current is also very much related to load as well. So it's all are related, and power is nothing but it's the product of voltage and current, or it's the rate at which the electrons are flowing at the particular point also can be explained. I hope you understand this video very well. Basics of electrical is clear to everyone. Please do subscribe our channel, share this video to your friends, so that this information or this new knowledge can be shared with everyone. And thanks for your support. Thanks for watching. We'll definitely see you in the next video. Thank you.